So initially they wanted me to start with using what's called like classical computer vision to detect lanes. That's like taking an image of the road and using like edge detection methods and then fitting a polynomial line to those edges where you might see the lane markings or the lane line. However, that was very unrobust. So I figured that out pretty early on, that I would sit there tweaking. Like classical computer vision algorithms have a bunch of parameters that usually come with them. So you have to sit there and tweak these parameters, and it's almost like you have to tweak it for every 2 miles of road to get it to work right, get it to be robust. So what I ended up doing was I basically thought, okay, like I need to use deep learning so it's more robust. However, I don't have a lot of data, so I made my own little like data labeling tool one day at work, and I just labeled like 100 of our images, and was able to train a deep learning algorithm on that. And the deep learning algorithm would produce this basically binary map of these lane lines. And that was much more robust. There's like, the deep learning model learns a bunch of these parameters. So it was much more robust, which made fitting these lane lines and fitting the lane markers much more robust as well. So I guess the most challenging part was robustifying the detection of these lane markers. Going from kind of it failing all the time to it rarely failing was a hard cycle to go through. Like just getting it to improve, 5% more after that would probably take another year. It's like it just gets progressively harder, exponentially harder. So yeah, I would say that was most difficult.
And how did you identify technologies that best suited the project? Did you conduct any research?
Yeah, so basically I had to connect, like when I first started working there, I already knew of deep learning. I knew that was kind of state of the art for segmentation. So what it really came down to was knowing, or like coming to the conclusion that classical computer vision wasn't robust enough, and then connecting that with kind of the state of the art research in semantic segmentation and applying that to the problem we have. So like I knew that deep learning was probably the way to go. So I used, TensorFlow, like Python, TensorFlow, and basically I trained up the semantic segmentation network. Then from there, like there's some research on fitting. So like once you have this kind of binary image of just black and white would be the lane lines or lane markers. What you have to do is, that's not really useful to drive. Like you need to fit what these like splines to those markers. So there's actually quite a bit of research on fitting like lines or splines to these lane markers vertically, so you can actually separate out the lane. So basically, I read a few research papers on how to robustly use like what's called RANSAC to fit a polynomial line. RANSAC stands for like random sampling census, I think it's called. And basically it robustly fits lines to a set of data points. And it's actually kind of funny because doing that would come from the old papers. So like I'd read these like older lane detection papers, and they still use classical computer vision, but then they had this lane fitting method. So I used the lane fitting method from kind of the older days, and then used the new state of the art deep learning method for actually generating that like binary image.
Oh, I see. That's pretty interesting.
Yeah.
Okay. And so, did you work with a team here?
Yes. So I worked with it was me and uh, two other people. So it was me, one other intern, and then my boss, and we were underneath him, or our mentor basically. Um,
Mhm. And were you undertaking this project for a client?
no, we were our own company, developing our own software. So it wasn't for a client; it was for ourselves.
And did you identify any opportunities to improve the company's internal business processes?
Um, Not really. I mean, other than building them a system to get lane data for.
Mhm.
I didn't build any other like internal like CI/CD systems at all like
Mhm.
that.
Okay. And how was the project received at the end by your boss?
Very well. Um, they really wanted me to like stay on to go ahead like to keep supporting it, and they wanted me to um, do full-time development on the mapping project after that. But I ended up taking a position at my current company now. So they really liked it. The the data that I generated for them basically was used to train out their my boss's like lighter weight models, which was used to drive our cars on the road, which was kind of cool. So I think my boss was, I think he loved it. Um,
Okay.
and he wrote a referral on my LinkedIn and stuff. So like I had a really good relationship with my boss there, and um, I think he really enjoyed working with me.
That's great. Would you like to add anything else to this experience?
Sorry, what was that?
Would you like to add anything else to this experience?
Um, oh, one other thing I would like to kind of, I don't know what the best way to tell people this is like, so to uh, basically temporally track lane lines, I use common filters. So it's like basically it is a way to like predict where like the lane lines might be in the next frame based on kind of like the equations that you build for it. And it'll like automatically weight certain areas of the equation to predict where it might be based on uncertainty. And
Mhm.
I I want to say in here that I built this lane tracking system as well, because I know a lot of the robotics jobs I've seen, they like to see that you have experience with um, like Kalman filtering or like Bayesian filtering, and I got that
Mhm.
with this with that project. Um, I don't think I have a point on there for that on my resume, but I'd like to like have that as well. Maybe
Okay.
in the same
Okay.
point, but somewhere on there. And I don't know if saying I did Kalman filtering is too specific or not. Um,
Uh, I'll be sure to keep that in mind.
okay, thanks.
Problem. And so your next experience is as at General Atomics as a computer systems and sciences intern. And can you walk me through your role here?
Yeah, so what I did here was I we had a bunch of old like hardware that was getting replaced. Um, so it was like I would update like old software systems, like these old legacy C systems, to work with our new hardware. And it was like simple scripts, like this is just when I was starting out in school, or like second year. So it was pretty simple software scripts, kind of upgrading these systems. I built a GUI application in Qt, so C++, and that helped with on-site. We had like these. I worked at the magnetic fusion facility at General Atomics, and like when any sort of magnetic fusion experiment would happen, like a ton of data would get generated. My GUI application would plot out that data, and basically what you see from that data is where like certain parts in the fusion facility is malfunctioning. So the electrical engineers would, my GUI was like up in like 5 different areas in the whole building, and they would like be able to easily see like, okay, what might have gone wrong in the last fusion experiment, and then go and like check it out. So, and that was all designed from the ground up actually with that GUI application. Then the hardware and supporting software that I upgraded, that was all upgraded to increase the amount of data they can acquire and decrease the time it takes them to get the data. I don't have any sort of like numbers on that end. It's just like I know time to acquire data decreased, and my GUI application helped out the electrical engineers. They didn't have to walk all the way to the computers at the opposite end of the office and then like manually run one of their scripts to see like what the data looked like. So that obviously helped them, but I have no sort of like number to say how it helped them.
I see. And did you have to make sure that the user interface complied with the company standards of how they view or manage the data?
Yeah, so actually it was quite a process. Basically, whenever like designing the system, like even if I had to be on the network or anything like that, I had to have like a meeting with like people like way over me at the company and like all the engineers almost, because it was so like security was so important there, and like kind of maintaining they like wanted to make sure that the software was up to their standards. So the data I would get though was passed to me from another program that they had internally. So that data would already be like, I guess, in the correct format, or would be secured or anything like that. I wasn't really handling the data. I was just taking the data given to me and displaying it for them.
But ultimately, you had to comply with the standards, right?
Yeah.
Okay. And apart from that, what were some of the other challenging aspects of this job?
I think the most challenging thing was like I'd come from someone that worked in Windows to having to work on really old Linux systems where there was no GUI, or there was no like desktop interface, and there was only VI, the editor. So I had to like learn to, SSH into these systems and edit programs with just VI, just compile code without an editor and all that. So I think that was the most challenging part, was getting used to, like, now I'm like really good at like terminal from that job actually. Like I'm really good with like Vim and all that. It was a pain when I first get it started going, but now it's super helpful to know all that stuff.
So you had to self-learn to work on that interface.
Yeah. It was the programming was not super hard. and it was just such a introductory position. But yeah, that was probably the hardest part. Was just getting used to interacting with the system, the interface.
Okay, perfect. And were you working independently here?
Yes.
See. And did they have you? I mean, they were undertaking this